All right, people. So, um, now we are going to begin talking about chemical equations. All right. Now, a chemical equation represents a chemical reaction, an actual chemical process that occurs, and it writes it down in the most simplified form. It writes it down in the most simplified form. It tells you how many moles react with however many moles. It gives you states of matter. It lets you know whether heat. Well, sometimes it lets you know if heat is released. It lets you know if the reaction can go forward or it can go backwards. It lets you know the states of matters of the reactants. It lets you know the states of matters of the products. It can be used to determine which chemical runs out first. It can be used to determine exactly how much product you're going to make, or it can be used to determine what ratio of masses you need so you won't have that much waste. Very, very important. Very, 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 very important skill. All right, so let's take a look at this. Now, this right here, this is an alcohol burning, right? So this is ethanol burning to produce CO2 and to produce water. All right. Now, over on the left-hand side of the arrow, on the left side of the arrow, we have the reactants. On the right side of the arrow, we have our products. All right. Now, it is always like that. Okay. Reactants on the left, products on the right. Now, every time you have a chemical formula, you should always check that elements are actually on both sides. Some of y'all will write down a chemical reaction and you guys will get rid of a substance and be like, hey, where'd it go? And you'll get things wrong. All right. Now, right now, this is just what a chemical reaction represents. Okay. Now, this is a really small section of notes, but let's kind of talk about what it is. Let's talk about what it is. So let's check some of these things out. All right. So let's take a look at this right here. So when natural gas, methane, combines with oxygen in the air and burns, it will produce carbon dioxide and water. When you're giving a sentence like that, you should be able to come up with a chemical reaction. All right, that is a skill you must have. So think of what things are reacting and think of what things it is producing. So let's think about it. Natural gas methane, CH4, combines with oxygen. So word equation, you just a little quick sketch like that, methane with oxygen. And when it says produces or yields, that's when you put the arrow. And it makes carbon dioxide. So carbon dioxide, pretend this is carbon dioxide, and then water. So that's your word equation. Your chemical equation, well, they gave us the formula for methane, that's CH4. And then over here, that's oxygen. Remember, there are 7 elements that are diatomics, that they exist as a pair. They exist as a pair. There's O2, H2, Cl2, F2, Br2, I2, and then N2. All right. So it makes a little 7. You start at N, O, F, and then Cl, Br, I. That's 6 of them, and then your 7th one is H. So on your periodic table, it makes a little 7, and the 7th one's over that way. Okay. Little quick way of remembering it. Now, getting sidetracked. Now, carbon dioxide. Well, carbon is C, dioxide, 2 oxygens, boom, and then water, H2O. So that is our chemical equation. It is not a balanced chemical equation, but is a chemical equation. Now, what you got to do is try to think logically what state of matter there are. All right. When natural gas is a state of matter, so we put a G, combines with oxygen in the air, so it's telling you it's a gas. and burns, it will produce carbon dioxide and water. So water, you know, it can be a vapor or it can be a liquid. You don't really know. You can say liquid, but if you knew that this was super hot, right, because you're burning something, it's most likely going to make a gas. But if you wrote liquid, that's okay. And then CO2, that's gas as well. Okay? Because, ooh, no. All right. Now, what does it represent? One thing you should know, or should try to familiarize yourself with, is a visual representation of what things are. Right? So for example, let's say carbon is a red dot. Red dot, red dot. And then hydrogen is the black dot. So this right here, well, there's 1, 2, 3, 4 things right there, okay? And then it's reacting with O2, and we'll make that one the blue dots. But remember, they're together, right? So it's 2 blue dots together like that. And then it's going to make CO2. Well, CO2, and then we're going to just leave the plus sign. Now CO2, we said, is a red dot. I mean, C is a red dot. And then we said O was the blue dots. All right, so we got that so far. Now for H2O, we said H's were the black dots. So we're going to have 2 of those. And we're going to say O's were the blue dots. Uh-oh. Whatever. Close enough. Close enough. Close enough. Now, let's take a look at this really quick. Over on the left side, we have 4 little black dots, or 4 H's. Over on the right-hand side, we have 2 black dots, or 2 H's. Over on the left-hand side, we have 1 red dot, or 1 carbon. Over on the right side, we have 1 red dot, or 1 carbon. All right. Over on the left side, we have 2 blue dots, or 2 oxygens. That looks like a 20. 2, whatever. All right. And then over here, we have 1 oxygen. So this doesn't really make sense because we have 4 hydrogens on the left, 1 carbon, 2 oxygen on the left, and on the right side we have much less. We're missing things. So we have to balance this chemical equation because this right here does not show the law of conservation of mass. Remember, matter is not created and it's not destroyed. It is rearranged. So we need to rearrange this formula so that the left and the right are equals. Well, how do we do that? Well, we add coefficients in the front of the chemical formula. So for example, we have 2 hydrogens that we need over, we have 2 hydrogens on the right, but we have 4 on the left. So you can put a number in the front to balance it. So we put a 2 here, it doubles everything there. And now we have 4 H's. So let's erase this. Now we have 4 H's. All right. We have 4 H's. And then now we have 4 O's. We have 4 O's because there's now 2 of these, right? There's 2 H2O's. There's 2 of them. All right, now let's see what else we need. We got 4 H's on the left. We got 4 H's on the right. We got 4 O's on the right. And then 2 O's on the left. So if we add another 2 right here, well, that doubles this amount. Right, so now I'm just gonna erase it now, and then now it makes a little bit more sense. Look, there's 1 carbon on the left, 1 on the right. There's 4 little black dots, 4 black dots on the right. There's 4 oxygens, and then there's 4 oxygens over here. So now that is what's actually happening. What's happening is one of these needs 2 of these to react to form 1 CO2 and 2 waters. That is what chemical equations represent. And so they show the law of conservation of mass. Oh, and you should have already drawn these, okay? These symbols. Ooh, I didn't get to talk about these symbols, right? So solid, liquid, gas. This is aqueous. The arrow means to produce or to yield. The triangle on the top, the delta. Whenever you see the triangle, that means delta. Normally, it means change, but when you write it on an arrow, that means that heat is added. So for example, let's say you want to light a candle. Well, you need a lighter, so you got to add heat. You got to add heat into it. All right, or setting a firework off, or lighting gasoline on fire, right? Anything you got to add heat into, boom, you got to put a little triangle. Now, when you see an element, it doesn't have to be PT. It can be any element or any substance. On top of an arrow, that means it's a catalyst. That speeds up chemical reactions. It makes them go by quicker, and but it doesn't react. All right. Balancing chemical equations. Do I got to do that? Show you how to balance chemical equations. We'll do these. These are pretty simple in the beginning. I got to give you more. All right, we'll do some simple ones, but we'll do this one right here at the bottom. So how do we do this? We'll do number 78. Well, you got to check. Well, there's 2 irons here and there's only 1 there. I highly recommend you leave elements that are by themselves to the very end. Focus on everything else first, and then fix things, okay? So let's check it out. There are 3 O's here and then 1 right here. So we have a total of 4. And then we have 1 C here. We have 1 C right here. Oh, I should let you guys struggle with this one. All right. But let's just say we put a 2 right here. Well, now we have 2 C's right here. All right. Well, I mean, we need 2 C's. If we put a 2 here, that's going to give us 2 C's. But our O's, look, now we have 3 plus 2. That's 5 O's, and we only have 4. So whenever you're stuck like that, you're going to need to find some sort of common multiple. And I think if we put a 3 here, that's going to give us 3 O's plus 3 O's. That's going to be 6 O's, 3 carbons. So on the right side, if we put a 3, that gives us 3 carbons, and 3 times 2, that's 6 O's. Now the only thing that seems off is the iron. Well, let's put a 2 right here. So now we got 2 irons on the left, and we got 2 irons on the right. It's all about keeping track with these types of problems, and it's all about practice. Some of you sometimes get tunnel vision, so if that happens, I recommend you skip the problem and come back to it. All right. One thing I want to talk about is the bottom before I go, is you're going to have to read these formulas and write down balanced chemical equations. All right. So when magnesium metal reacts, well, metal, what state of matter do you think that is? Hydrochloric acid. Every single acid is dissolved in water. When something is dissolved in water, what state of matter is it? It starts with an AQ and it rhymes with aqueous. All right. So you got a lot of equations to write. Write them out. Balance them. And that'll be it. Okay. Peace out.